As we wrap up our last chapter, or our last sections of the chapter, it means we're honing in on a test. So our test will be next Tuesday. Okay, next Tuesday. So we'll do inequalities today and tomorrow, and then we'll do a review day on Monday, and then we'll put everything together for the test. I really encourage you to study your quizzes before you take the test, because the quizzes are the best. If I thought it was important to be on a quiz, it's probably going to be on the test too. So this last thing is a review. Inequalities are not anything new. You start learning about inequalities in elementary school. All right, when they use the little the inequality symbol, did they ever liken it to an animal? A crocodile or an alligator, maybe? Okay, and what side did he always face? Always face the bigger number, right? Always have its mouth open towards the bigger number and away from the smaller number. All right, so inequalities. You're pretty comfortable with inequalities. What does the line underneath an inequality mean? Okay, it means it includes that number. Okay, all the way up to, but includes that number. Some people in real life, they get inequalities wrong. So for example, I saw a sign talking about prices to get in, and it was like, if your age is less than 2, did I tell you this already? If your age is less than 2, it's free, and if your age is greater than 2, it was like $5.
When you're 8 years old and your parents trying to get the 2-year-old.
I'm like, well then, what's the problem with that inequality?
Well, what is the 2?
Okay, what do you do if you are 2? Because the thing said less than 2 or greater than 2. Well, what do you do if you are 2? Okay, and then what happens? Okay, so that person clearly did not understand how inequalities work. All right, intervals. The way you write it as an interval. Now, those words both start with the letter I, so you got to be careful when you're reading a test or quiz. Did she say interval or did she say inequality? So you write it correctly. Here's how you write it as an interval. You'll take the numbers -1 and 4 and you'll separate them with a comma. So there's no x anymore, there's no variable, it's just a comma between them. Because the 4 is the equal to part, it has a bracket. And that's how you show that it's equal to 4. And then because the -1 did not, you have a soft parentheses. So that would show that it would not be equal to -1. Yeah, that's not my favorite. Okay, I don't like it. My personal reason why I don't like it is because what if it's written like this? What does that look like? What else could that have mean? It could be a point on a graph as well. So how do you know? Are they talking about an XY coordinate graph or are they talking about interval notation? So that is my personal reason of why I don't particularly care for interval notation, but it does show up. Let's go all the way to the end and let's do this on a number line. What would this look like then on a number line? And so number lines are going to be centered at 0. We've got -1 and 1, 2, 3 up to +4. On a number line, you're going to put circles on both 1 and 4. You'll shade between them to indicate that this is representing any number that falls between that set. And the last thing you're going to do is fill in the circle for 4 because it is equal to the number 4. So what's the smallest number in this group? What is the smallest number in this group? -1 is not in the group. It's not including -1. So what is the smallest number in the group? 9 repeating, right? -0.9 repeating. That is the smallest number that you can get into the group. Okay, -0.9 repeating because we do not include -1. What's the largest number in the group? 4 is included. All right, so then how would you explain that in words? So this is where I get to zoom in and write really small. Okay, so something like this. All numbers between -1 and 4, always list the smaller number first, and also including 4. So by the virtue of the fact that you did not reference including -1, then you would know that it would not be including that. So that's how you would explain that in words. All right, let's look at the next row. I've written words for you. We're going to see how that is. I've written the word positive real. So let's start with a number line. how do we draw positive reals? All right, well, here's our number line. Where should I put a circle at?
0.
I should put a circle at 0. And if I want positive, which direction should I draw?
Right.
To the right. Now the question is, do I fill in 0 or not?
Yes.
Is 0 a positive number?
Yes.
Is 0 a negative number?
No.
0 is not a positive number either. Okay, and 0 has no sign. It's not positive or negative. It's between all positive and negative numbers, so we do not include 0 because it didn't say positive reals including 0. It just said positive reals. So what's the smallest number in that set?
0.1, like zeros, lots of zeros and then a 1 eventually.
All right, so if you listed lots of zeros and then said 1 eventually, could someone come along and find a number smaller than that? What would they have to do?
It's like infinity zeros.
They just have to insert a couple more zeros, right? So is it possible to ever find the smallest number of this set? Okay, no. What about the largest number of this set?
No.
What is the largest number?
Also infinity.
Okay, it's infinity. So we're going to use that when we write our interval notation. So we are starting with 0, comma, ending at infinity. We are not including 0, so we put a soft parenthesis. We are also not including infinity because it's not possible to ever find the largest number. It's not possible to find the smallest, and it's not possible to find the biggest. So we write it like that, soft for both. And then for our inequality notation, we've got 0, less than x, less than infinity. Neither of them have lines underneath because we're not able to come up with, to be equal to either of those. All right, any questions on that one? Okay, so positive does not include 0, neither does negative. They would have to specifically say including 0. All right, the last one, we're going to start with our number line and work backwards. All right, on a number line, you might see this. And on the number 3, you might see something that looks like this. It's not a closed circle, it's a bracket. It's another way of writing that same thing. All right, so do you think that includes 3 or not?
Yes.
Yeah, because it's a bracket. Brackets always include. And then let's go down this way to the left. So what is the largest number in this interval set? What's the smallest number in the interval set? Negative infinity is the smallest. And so let's write this as our inequality notation. So we'll have negative infinity up to 3 and including 3. So we put the bar underneath because it was the bracket on the number line. In interval notation, you'll have negative infinity, comma 3. The negative infinity will have the parentheses, whereas the 3 will have the bracket. All right, does anyone want to take a stab now at describing this interval set in words? All numbers what?
All numbers less than 3 or equal to 3.
Okay, and including 3. Very good. All right, so all numbers less than 3 and including 3. Or you could say less than and including 3. So the first half of your homework is all about those different forms of how you could write stuff about inequalities. So you'll be changing, they'll give you one form, maybe they'll give you the words, and they'll ask you to come up with the other ones. Or they'll give you the interval notation and ask you to come up with the other ones. And so it's just a mixture of you understanding all the different kinds. Does anybody have questions about that? So those are the four things. Okay, then to finish up, we'll do some actual math problems with inequalities. when we solve an inequality, a couple of you during your quiz asked me, again, what does solve mean? Like, how far do I go? When you solve an inequality, you want to go all the way till x is by itself. All right, that's our goal, is to go all the way until x is alone. All right, so let's say we have the number 3 outside of the parentheses, x minus 1 plus 2 less than or equal to 5x plus 6. All right, so 3 outside of the parentheses, x minus 1 plus number 2 less than or equal to 5x plus 6. So we're going to solve this, which means go all the way to where x is by itself. All right, first step. Distribute what? Okay, distribute the 3. When we distribute the 3, we'll have 3 distributed to x, and then minus 3 plus a 2 less than or equal to 5x plus 6. Now I want to combine the like terms. So I have 3x minus 1 less than or equal to 5x plus 6. Now to solve means to get x by itself. And right now I've got 3 x's on one side and I have 5 x's on the other. So how would I work towards getting x by itself? What should I do to both sides?
Subtract the 6 from both sides.
Okay, I heard lots of viable things. I heard subtract the 6, I heard subtract the 3, and I heard subtract the 5. Okay, and nobody really said anything about the 1, but yeah, okay. So there's several different things. I'm going to pick subtracting the 5. Okay, so I'm going to subtract the 5x. All of those other things would have worked too. They would have been fine first steps. This gives me negative 2x plus 1 less than or equal to, and I have the 6 left by itself. Now I don't want to get it set equal to 0. I want to get x alone. Yes, sir. All right. Oh, minus 1. Thank you.
Good point.
All right. Well, let's deal with that minus 1. What should we do with it? Okay, let's add it to both sides. So that's going to give me negative 2x less than or equal to 7. Now what do I do? Divide by negative 2. Okay, why and flip?
Because if you divide by a negative number, you flip this.
Is it only when you divide by a negative number?
Is it? Because that was my question, because I didn't do it like
I flip it
that.
whenever
Okay.
I studied.
All right. When do you flip it? You flip it when you divide or multiply by a number that's negative. You do not need to flip it if you divide or multiply by a number that's positive. Only when you divide or multiply by a number that is negative. So because I am dividing by a negative number, I will flip the sign around, and that will give me 7 divided by negative 2, or negative 7 over 2. Only dividing or multiplying by a negative number is the rule. All right, so let's put this onto a number line.
We're going to be drawing a lot of number lines.
You will, sir. So negative 7 over 2 is negative 3.5. And so if I mark out where negative 3 is and I mark out where negative 4 is, I want negative 3.5. So I'm going to draw this one like a bracket because it is including that number. So it's negative 3.5. And I will be going greater than, x is greater than, so I'll be heading off to the right. An arrow showing that it goes on to infinity. So if you need to, make an official, okay, flip the sign only when multiplying or dividing by a negative number. All right, our final example for today. And then just think, we have one lesson done, and then we've got our whole first chapter finished. All right, our final example, I'm going to ask you to solve the following. Negative 3 less than 2x plus 6 over 4 less than or equal to 5. So this is something that's got a double inequality in it. It's got an inequality on the left and an inequality on the right. We still need to get x by itself. Thankfully, we only have one of those. What do you think my first step is? Multiply. Okay, I want to work toward getting x by itself. What am I going to multiply by, Daniel? I'm going to multiply by 4. And that has to happen on the two outside ends. I got to multiply the front end and the back end, both multiplied by 4. Now, I'm not multiplying by a negative number, so I don't have to switch any of the signs. So I'm going to have negative 12 less than 2x plus 6, which is less than 20. So what I've done is I've gotten rid of the 4 in the denominator by multiplying everything. Now what will I do to all the parts? Okay, I'm going to subtract the 6, and I'm going to do it from the both ends. That's going to give me negative 18 on the back end, and it's going to give me positive 14 on the right. Or equal to. And then my last step would be to divide everything by 2. And again, I'm not dividing by anything that's negative or positive, or not dividing by negative numbers, so I don't have to change the sign. So I'll have negative 9 less than x less than or equal to 7. And I'll graph that on a number line. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, negative 9. Now you may either use open or closed circles, or you may use parentheses or brackets. It doesn't matter to me. If you're going to use parentheses, you would do a parenthesis on the 9 and a bracket on the 7, and then shade in between. If you're going to use open or closed circles, you would do an open circle on the 9 and a closed circle on the 7. Either way, both are legitimate and viable answers, so I don't have a preference really either way, whatever you like to do. So that's a sort of a review of inequalities. None of this should be brand new things to you, just reviewing what you knew before. And then tomorrow we'll wrap up inequalities, which wraps up our first chapter.